Hello there. Today we're going to be doing linear algebra. So let's choose like purple font. Okay, so linear algebra. So linear algebra is a study of linear equations. Going to be going through chapter 1 of the book. It's called Linear Algebra with Applications. And it's the 6th edition. Is by W. Keith Nicholson. So you can find that in the link in the description where you can buy that book to follow along or find it online somehow. So that's the book I have. I bought it about 9 years ago. So they may have new editions now, but regardless of what edition you have, I'm going to write down each question as we go. So this book is a basic introduction to the ideas and techniques of linear algebra for first and second year students who have a working knowledge of high school algebra. It's first and second year university. Its aim is to achieve a balance among the computational skills, theory, and applications of linear algebra while keeping the level suitable for beginning students. The contents are arranged to permit enough flexibility to allow the presentation of a traditional introduction to the subject or to allow a more applied course. Calculus is not a prerequisite. Places where it is mentioned may be omitted. Okay. So let's just crack into it. So let me just delete this. So that's the book right there. Link below. But I will be posting every problem as we go and writing the entire thing out. So you don't really need it, but it's helpful to read the book and follow along. I recommend getting it if you have, the money, but it's not necessary for this course. Okay, so change to a brush here. Okay, let's test. Okay, you can see that pretty well. Perfect. Okay, so what is a linear equation? Linear equation. A linear equation is of the form. I'm going to use the text tool actually. It's of the form ax plus by equals c. So that's a linear equation, meaning that every variable x and y is to the power of 1. So another way to write this would be a1 times x1 plus a2 times x2 plus a3 times x3 plus dot 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 equals constant. So this is a linear equation, in case my writing here is pretty messy. So here this is a subscript. It's a subscript 1 times x subscript 1 equals this, and then you can have as many variables as you want. That's up with a dot dot dot. And it's equal to a constant. And the constant can be 0 or it can be any real number. So, and all the a's, all the a1, a2, a3 are just real numbers. They're constant real numbers, not variables. They can be 0, or they can be any negative number, or any positive number. But they're not complex numbers in this case. They're just real. So here's a specific example of one. It'd be 2x1 minus 3x2 plus 5x3 equals 7. So here, a1 is equal to 2, a2 is equal to negative 3, a3 is equal to 5. There's only 3 variables total, x1, x2, and x3, and the constant at the end is equal to 7. Another way to write this would be 2x minus 3y plus 5z equals 7. So because we're in 3 dimensions here, we have 3 variables, we can write this equation of a plane here. This represents the equation of a plane in the real Eulerian geometry. Anyways, so given this equation here, you can make a vector x1, x2, x3 dot 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 is going to be equal to some set of values called the solution. So s1, s2, s3. So each s1 is a value you input into x1 that satisfies this. So this is a solution vector. So all the x's make a vector, and this is a solution vector. Once I get a trackpad and I can actually write down the way it should look as a vector, it would be more clear maybe, but for now, this is all we got. So, so here's an example. So here we have, here's a system here. X plus y plus z equals 3. So this is a 3 variable system. All the constants are equal to 1. All the variable constants are equal to 1, and the constant term at the end is equal to 3. So here for the solution space, remember that we have a vector, or which could also be called x1, x3 in this case. Here our solution space would be 1, 1, 1, 1. And all I'm saying here is that x equals x1, y equals x. This is just different ways of saying it. You can either use x, y, z, then QRS, as many as you have. You can keep going if you have a 4-dimensional system. But here, 2 different notations for it. And clearly the solution here is 1, 1, 1. So before, as I said, equal, this is a solution space. So when you plug in the solution space into this, you get, or the solution vector, you get the solution, and it works. So clearly 1 plus 1 plus 1 equals 3, and this works. Okay. And another one would be 2x plus y plus 3z equals 1. So here we're going to try to plug in x, y, z equals 0, 4, -1. So we're going to plug that in. I'll give you a second to try and figure that out. Okay, I'm back. So the solution, we have 2x plus y plus 3z equals 1. So we have 2 times 0 plus 4 plus 3 times -1 equals 1. We have 0 plus 4 minus 3 equals 1. We have 1 equals 1. So solved. So there we go. So that's all you do there. You just plug it in. So now we have, so sometimes when you have a system like this, you can have a system that has no solution. So you can have these variables here, but there's no such x, y, and z that could possibly solve your equation. So wait, let's go back actually. So here we have let's say we have two equations that relate the same variables. So let's put our other equation back now. Equals 1 equals 3. So we had the solution. We had x, y, z equals 0, 4, -1 as our solution. So let's say we have a system of linear equations here. This is now a system of linear equations. So that means that this vector has to satisfy not only this one, but also this one. So our solution has to satisfy every equation in the system. So let's test it out. So we know from before that we're going to have 2 times 0 plus 4 plus 3 times -1 equals 1. And this works out to 1 equals 1, so true. Now let's see the other one. So now we have for the equation x plus y plus z equals 3, we have 0 plus 4 minus 1 equals 3. 3 equals 3, which is true. So therefore, this vector satisfies both equations in the system of equations. So we can say that the system of linear equations has a solution right here. This is the solution to the whole system. So before we had, for the other vector 1, 1, 1, this is a solution to this one, but this is a solution to this one. So let's test that out. 2 times 1 plus 1 plus 3 times 1 equals 1. 6 equals 1. False, not a solution. So therefore, this vector only satisfies this equation and is not a solution to the system of equations. Okay, so that's that. So example 1. Let's say we have this system here with 4 variables. This is our system. 4 variables, 2 equations. So here are the equations. x1 minus x2 plus 3x3 plus x4 equals -3. And then we have 2x1 minus x2 plus 3x3 minus x4 equals 0. Those are our 2 equations. And here's the solution that we're going to test for the variables. So the solution we're going to test is going to be x1 equals t minus s plus 1, x2 equals t plus s plus 2, x3 equals s, and x4 equals t. So you might be wondering why we have t and s in this, but that'll become apparent later. So all we're testing right now is if you plug this in, are the equations satisfied? So let's plug it in and find out. So equation 1, I should have copied it. x1 minus x2 plus 3x3 plus x4 equals -3. We have t minus s plus 1 minus t plus s plus 2 plus 3s plus t equals 3. we got collecting the t's. We have t minus t plus t. Wait, actually it's 2x2 here. This is a 2x2. So, my bad, wait a minute. So the equation is actually 2x2. So, it'd be 2 times this. So t minus 2t plus t. Then collecting the s's, we have negative s plus 2s plus, or minus 2s, minus s minus 2s plus 3s. And then for the constants, we have plus 1 minus 4. Right. Equals 3. Okay. This looks wrong. Equals negative 3. Oh, it's a negative 3. There we go. Equals negative 3. There we go. I'm happy now. Okay, so the t's clearly cancel out. 2t, t plus t, t plus t. See my mouse? This goes to 0. This is negative 3 plus 3 is 0. Here you have negative 3. So you get negative 3 equals negative 3. True. Equation 1 satisfied. So you'd say, okay, then we do equation 2, which was 2x1 minus x2 plus 3x3 minus x4 equals 0. So we get 2 times t minus s plus 1 minus t plus s plus 2 plus 3s minus t equals 0. So computing this and taking all the t's, you have 2t minus t minus t. You get minus 2s minus s plus 3s, and then plus 2 minus 2 equals 0. So clearly this works out. You have 2t, 1t, 0t, negative 2s, negative 3s, 0, positive 2, negative 2, 0. You get 0 equals 0. True. Oops. True equation 2 is satisfied. Okay, so here you can say, therefore, for any s and t in the solution vector, the equations will be satisfied. So here you have what this just teased out of the thing, of the system of equations, is that you have these two parameters that can be anything, and you have these two equations that are satisfied. So whatever these parameters are, the equations will be satisfied. So there you go. So they're called parameters, and the reason we have 2 is because we have 4 variables and 2 equations. And so when you do 4 variables minus 2, you get 2. And that means you can have 2 parameters in this system of equations that can be anything, and it'll still be satisfied. So that'll become more apparent why that is later. But for now, just keep that in mind. Let me erase this. Sweet. Okay, I'll be back in a second for part 2. So like, subscribe, comment. If you want private tutoring, send me a message or leave a comment and we can get in contact. Thank you.